As part of this discussion, we kind of mentioned it briefly, the opportunities for waste conversion facilities and other types of blue economies that could be generated around Laguna Salada and the Salton Sea, but really the ubiquitousness, it could be generated anywhere. There's a need to process waste products, and there's a need to do that in a sustainable way. So we brought this point forward, and I want to introduce Dr. Andrea Neal. She's one of the founders of Bring Back the Blue, and she's been actively working in collaboration with us on this project as a whole, but more specifically on the element of blue economy and the waste to conversion facility. So I'd like you to take the freedom to talk about whatever you'd like, Dr. Neal, and just kind of feel free to have this as your time to share. If we have Q&A, I'll try and help out with that, but if not, you can just use that whole half hour before we turn it over to Michael Theroux. So I'll let you take the helm.
Why don't we go ahead and put Michael in the text boxes too? So.
I'll bring him up too. The nice thing is that we can share your faces. Thank you so much for joining us, Michael. Let me bring that here. We got you pinned. Yeah. So basically, I guess the first conversation is this becomes one of those financing elements. The discourse that we just had right now. The state of Mexico, the federal government of Mexico, the state of California, the federal government of the United States, that's their first question. Is this a viable project? Is it financeable? So that becomes the opener for this. And take it away.
So just another note, Nathan, can you allow me to share my screen?
Do that right now. Yeah.
Thank you.
Or Horatio can help me out with that. He's on the other screen.
Okay. There we go. Screen sharing going, and I'm going
to
present this. Come on, technology. You can do it. There we go. So as Nathan has said, my name is Dr. Andrea Neal, and I'm here with my very good friend, Michael Theroux. And Michael is an amazing individual who I've been working with for a few years now on various technology and conversion projects, not only in the state of California, but across the world. And so we're going to start today in two parts. The first part, I'm going to overview a little bit more on blue economy and blue economy development. And then Michael's really going to take the technical aspects of what we're doing here. And Michael himself is this amazing Renaissance man, and I've gotten to know him really well over the last few years. And he has over 35 years of experience in this space, from municipal waste collection and conversion to what's happening in the conversion technology space. But he's also had a lot of experience in this region in Southern California and has been on the forefront of developing the plans and the planning phases for conversion technology programs for Southern California. And then my background is not quite as straightforward into that space. I've been in the marine litter space for more than a decade, looking at solutions to environmental problems and really thinking about exactly what we've been talking about. How do we find financing for these projects? How do we create solutions, environmental solutions that have a business sustainability background to them? So I'm going to try once again to share this. Okay, there we go. All right. And I can't see what that's looking like on your guys' screen. Are you seeing the entire presentation or?
Well, Andrea, you've got your files identifications off to the right-hand side, so you're not picking up the whole screen.
Okay. Why is it not letting me do this?
Ghost in the machine.
Let me go to Zoom, and is there a way to do the?
I think it's just a full screen. In the screen that you're sharing, you just got to make it full screen.
Okay. That's not what I was trying to do.
Back, Andrea.
I'm usually much better at this. So hold on. There's the. Is that it? Full
That's your
screen.
smiling face.
Okay, so you're still not seeing the full thing?
It works okay for where it is, if you like.
Yeah, it's viewable. If you click on the other one to make it full screen up there at the top, down below that, within there, just click on the ones to make it full screen.
Your screen, Andrea.
On my screen?
On your presentation, yes.
I'm going to stop share. And okay. I'm not sure why this won't. Oh, there we go. There we go. Okay.
Now share screen.
Now share the screen. Okay. All right. Is it still partial or?
I don't know, Nathan. Looks good to me. Does to you?
No.
There we go.
That's why I'm concerned. I think Google has decided to not be great to me today. Okay. So you guys are seeing that okay? Okay. So I'll start with my portion, which is more on the blue economy development part. And I've been thinking a lot about plastics and carbon offsets, which are big key components to these projects and how we develop financing for them. And the plastic and the carbon offset space, as we're seeing it develop and move, will be the next biggest monetary trading system globally, which is where we have opportunities for financing projects like the restoration of Laguna, Salada, the Salton Sea, and the Gulf of California, as well as major economic development programs like conversion systems, both on the United States side as well as on the Mexican border side. What is going on here? Okay, so I just wanted to kind of show you guys a little bit of a picture to show you that I'm not always on the business end. I come from a scientific background. I have a PhD in molecular genetics and lipid biochemistry. I led some of the first expeditions looking at microbe interactions with microplastics in open ocean. And overall, I've done about 9,000 nautical miles of research on marine litter, which led me into the for-profit space looking at environmental detection systems and bioremediation systems, which then led me into developing sustainable groundwater development companies, and then led me into looking at how to create a economy that is a circular blue economy that supports the efforts of restoration, remediation, while building up good jobs that are well-paying no matter where you are in the world. So Bring Back the Blue is a really interesting company. We're a women-owned company, and currently right now, all of our pickup partners are women, and diversity is really important to us. And we designed Bring Back the Blue to be a blue circular economy model for monetization of non-recyclable plastic, blue energy production, and financing the cleanup of marine litter from open ocean. And I wanted to go through this a little bit, even though it's a little off topic from where we're going in the conversion space for this specific project, because this kind of thought about economy development can be placed into many different avenues of sustainability. So the way our company works is we sell offsets to meet either mandates or recommendations that companies are moving forward on, either voluntarily or they have been told to do so by their industries. And we take the money for that offset and we put it into operations of the program, and then 70% of it goes into blue economy development programs. And these include paying people a fair wage to remove plastic from open ocean, paying people a fair wage for removing marine litter and plastic litter from coastal regions, and doing fishing for plastic programs, edutainment and stakeholder development, and artists who are communicating these issues. and the plastic conversion programs of taking these materials and creating energy and raw materials and other products like building materials out of them. And you may ask, well, why is this really important for this region? Well, the unfortunate thing is that we have a plastic crisis. We produce a tremendous amount of plastic material every day, and it is entering into our food system, and everybody is eating thousands of plastic particles every day. Plastic is now shown that it leachates, so phthalates that leach from plastics in open ocean, impair growth and oxygen production in phytoplankton by up to 50%. We are finding phthalates and plastics all throughout people, including children. And we're also finding microplastics in 90% of table and sea salt. And recently there was a publication that even indicated that phthalates leaching for plastic will be an impact for human production because it reduces sperm count in men. And that's not just in the men that are getting direct impact from it, but generationally as well. So the blue economy, which is a really important part of our overall economy, and most people don't think about it, but plastic debris has been impacting our blue economy in a big way, and it's costing the world about $13 billion per year in economic damage. And this is damage to fisheries, this is damage to critical keystone species, this is damage to tourism. It hits us in all parts of our economic development. So it is something that is important for countries and individuals and regions to think about. And one of the things that has come out of this is that when we look at plastic production ourselves, it's not stopping. And it's used in a lot of really useful things across the world. But annually, we're producing 360 million metric tons of plastic debris. And about 11% of that is entering into our environment through oceans and waterways every year. And what we've seen is that the packaging industry and the plastics industry are all now making mandates for reduction and recovery. Companies are signing on to neutrality issues and neutrality commitments. And what's been shown, which is really interesting, is what is the economic impacts of this. If we continue as we are with continuing leaking plastic into our environment like we are, it is going to cost us $940 billion a year. But if we start creating and generating circular economy systems, this impact will be drastically reduced by almost $300 billion a year. So I wanted to also look a little bit on the American side because I had data that I could look into and think about on the American side. And so I took data on residential plastic waste, and I did compare the business waste, but it was a small smidgen of the overall impact. And I looked at waste coming from Imperial County, waste from Riverside County, waste in Los Angeles County, and waste in San Diego County, San Bernardino, and Orange counties. And the main reason I looked at this was to determine if there was enough feedstock. If we were to put a conversion site with the intent to generate gas and fuel for the restoration projects, would there be enough feedstock to continue this program as an economic development program after? And it's really interesting because what I found from doing this small data accumulation was that we produce a disgusting amount of plastic trash, a majority of which is non-recyclable. And so we're producing in the Southern California region about 333,000 tons of residential plastic waste a year. And I also realized that a majority of that is these other plastics, which are plastics that just don't have a chance of either being transported to places that are taking recyclable plastics and are really hard for our municipality systems to go ahead and put into recycling systems because they're either thin film plastics or they already have things on them, or there are types of plastics that are not readily recyclable. So we do have a need in this region for having a place where we can bring our non-recyclable and hard to recycle plastic trash. There should have been one right before that. The other thing I was looking at is the cost of the pandemic. So I found some papers in China that were talking about mixed municipal waste, and they found that during COVID they had a reduction of that by 30%. However, they had an increase in medical waste plastics by 370%. And why that's a really key important part to think about is that medical waste plastics are much harder to deal with than other mixed waste plastics. And they're about 24 times more expensive to deal with. So not only are we seeing an increase in products that we have to figure out a way to recycle and deal with, we're also seeing a product that's much more difficult to handle and also is much more expensive to our economy to deal with. And I also wanted to look at what is the current state of what's happening with China. So until recently, China was taking about 72%, almost 73% of the world's exported plastic waste. And what we saw with that is that up until about 2018, when they started to come down very hard with their national sword policy, which was preempted by the green fence policy, is that we have not had a place to put all of this trash. And it's estimated by 2030 that there will be an cumulative 111 million metric tons of plastic waste that is displaced without a home. And we're also seeing that our production of plastic waste is not decreasing at the rate that we're trying to meet our mandates for. And currently, the United States, up until recently when a lot of these hard mandates came down the line, was responsible for about 12.4% of the world's exports of plastic waste. And if you look over here on the right, what we also see is the California data on this. And so California, as recently as 2019, was exporting 14.4 million tons of plastic waste for recycling. And this next slide tells us why that is an important number to think about. So the Basel Convention is one that is talking about the control of transboundary movements of hazardous waste. So that combined with the mandates coming from China, and which is having a downward stream effect on other countries that we export waste to, so other countries in Southeast Asia, as well as the Basel Convention that talks about what we're allowed to send transboundary, is heavily reducing our ability to ship our waste to other places. So what that means is we need to find solutions now to how we're dealing with waste here on our soil and close to where we produce our waste. So for instance, right now by the Basel Convention, the only product that can be exported without consent is plastic scrap that is pre-sorted, clean, and uncontaminated, meaning not touched by food, and destined for environmentally sound recycling practices. All other waste needs to have permission or is not allowed to be shipped for these purposes, which heavily reduces our ability to find a place to place our trash. And so when we think about the solution to these issues and we think about, all right, we have a tremendous amount of waste that's being built up that has little to no value currently in the current economic models. So recycling companies and waste management companies are having a hard time finding buyers and finding where they can actually meet the margins to make it profitable to do anything but send this to landfill. We're seeing 11% of our trash entering our rivers and waterways, further impacting our blue economy and impacting fisheries and impacting coastal areas and recreational activities and tourism. And we're also seeing where the conversion facilities are having some of the issues of getting up to speed with dealing with this demand, because some of the laws and regulations aren't really in concurrency with where the industry is today. And so there's a lot we have to do to fix this cycle. But once we start fixing the cycle, we can think of a blue economy development where people are being paid a fair wage to clean up the environment, which benefits us all, which is sent to conversion sites and facilities, which produces clean energy for people, and also new products like building materials that are long lasting. We have a process that can be verified through modern technology and blockchain. So we know that when people commit to saying that they're doing things, that they are doing it, and that we're being as efficient as we can with our products. And when we provide value for those materials, then what we do is we actually generate a culture where people don't throw away their trash, but they keep it because it actually has value. It's not something that you can throw out the window and it doesn't cost you anything. Now that bottle that's thrown out the window actually has a substantial value to it. So when we think about plastic conversion, energy, raw materials, it cleans up communities via non-recyclable and removal and appropriate disposal of ocean plastic. So think about community-centered industrial centers, waste plastic to fuel centers that reduce our plastic footprint, reduce trash footprints, which is all mandates in the state of California and nationally and within other countries, generates a tremendous amount of jobs, generates new energy resources, which can have multiple inputs into the marketplace, which include things like no sulfur diesel fuel, direct to energy resources in the energy grid, new resins for production of new materials, hydrogen fuel cell development, syn fuels, avgas. There really are an endless amount of ways that we can work and play and enter the marketplace once we have conversion facilities that have tried and true methods, but also work on improving these methods and multiplying the technology together so that you have these multiple exports and opportunities. One company that we work with at Bring Back the Blue is Continuous Materials. And Continuous Materials is an amazing company that has been removing waste plastics out of the waste stream and converting them into flat top roofing materials. And last year they converted 10 million pounds of waste, and they expect to do more than that this year. They are one of our partners at Bring Back the Blue, and we're looking at things of even taking hard-to-use materials like derelict nuts from open ocean to move into the production of these materials. But these things are all things that can be done in the Salton Sea area. Oh, I didn't want to put that. So one of the areas that we were looking at strategically as a starting place for a conversion facility site, but there are opportunities on both sides of the border. It's just this particular site we were looking at has permitting in place and has infrastructure in place that will allow us to move quicker than we could in other spots. We were looking at the Mesquite Regional Landfill, which right now is not doing as much as it could be doing. It's on a rail line, so it has access to other parts of the state. And right now, no matter who does the restoration process, there is going to be a distinct need for fuel to operate that restoration. And when we did our numbers for the restoration project, we realized we needed about 9,000 gallons per day of diesel fuel for the construction vehicles used in the restoration process. And that will be about how much, no matter who does the project, how much the construction vehicle cost will be in gasoline. And when you look at the amount of money that it takes to purchase 9,000 gallons per day, it is actually cheaper to develop a conversion facility site, which generates jobs, is an economic development program, creates industry in the region, and creates valuable, long-lasting resources for the area, as well as getting rid of our tremendous waste plastic problem. So for me, this is a natural fit in the restoration process of both how do we find ways to support these projects through clean energy production, how do we continue to clean up our environment, and how do we continue to clean up our planet through technology and communicative thinking, and how do we generate jobs for people who desperately need jobs right now. So this is me. If you have any questions, you can reach me at Andrea at bringbacktheblue.blue. And I am going to turn it over to Michael for some of the work that he's done more on the technical end. And Michael, I can't see what the audience is seeing, so I need you to tell me if this looks okay for you on the screen.
There you go. Works great.
Okay, great.
I think you're on the very last slide, however.
Well, it's the important one. It tells people who you are.
Up to the top. There we go. Let's start there, and I'll kind of raise a hand when I want you to click down one. Thank you, Andrea. Good afternoon, everyone. Quite a process we're involved in here. I guess the first point is what is this thing we're talking about, conversion technology? Let's get our feet down on that a little bit first, because it's extremely broad topic, and it isn't one thing we can do. It is everything we can throw at it. We've got all kinds of diverse waste of all sorts of places, and we need all kinds of ability to turn that waste back into something that we can work with, some kind of conversion. So yeah, the next one there. Make it simple. The process itself, you've got all these various inputs. You've got a process somewhere that you've got to locate, and you get all these various outputs. And you break the model down economically and infrastructure-wise so that you can kind of fill those boxes. Give you some bright lines to work with and allows you to break projects into pieces. The next 3 slides are grouped types of conversion systems by category. This happens to be a biological. I don't want to go into too much detail. I want you mostly just to get the idea that we're not talking about one-trick pony here. We've got technologies that have been developing worldwide over the last century, and many of them have come to fruition in the last 10 years. You'll recognize some of these pieces in here. Some of these you may not. Microbial fuel cells are an odd, wonderful tool that we've got, for example, that is much more better known in wastewater treatment. To the next. Next slide, Andrea. One great big area and one that's pushing ahead right now an awful lot is when you work with motion and chemistry. And those two things can break down most waste one way or another. Our national labs and international universities are working in this space to find methods, technologies, techniques that can turn the crap we throw away, pardon my French, into the things that we actually need. And this has moved forward rather dramatically in some areas. Nanotech, one of them, anionic liquids, for example, that can tear apart just about anything. So kind of keep in mind that chemical kinetic is one of the major conversions. The next slide, Andrea. Now, much of the actual conversion of waste needs to be managed with heat. Heat everything from just drying all the way up to that sun-grade heat of plasma. In the middle of all of that are moderate temperatures that we know how to control well, that have been in, the technologies have been in use industrially for 50, 60, 100 years. Pyrolysis is one of those in the middle that is extremely useful, for example, for plastics. However you drive it, whether you heat a bucket without oxygen in it and put your plastics in it, it vaporizes it, if you will. And once you get plastics or many other wastes into some kind of a gaseous form, you run them through catalysts, you separate them out, and you find that you have the ability then to purify that vapor, if you will, into many different products. A lot of those products we use as fuels. There's a lot of categories. a lot of specialization on that. But thermal systems themselves are one of the keystones for large integrated conversion facilities for wastes. Kick into the next. You don't want to treat all things the same way. You kind of want to take the wet stuff and keep it wet, and the dry stuff and keep it dry, according to the EPA. That's been a rule of thumb for as long as I've been working in the space. And here's an example of a very simplified how you would work with food waste. You collect it, you sort it, you clean it, you pre-treat it, and make it into a material that goes into a bucket. You feed that bucket you put the bugs in the bucket that eat that waste, and it breaks it down into a biogas. To extremely simplified there, but you get food waste and other organics into a gaseous form that you can turn into fuels and other chemicals and products. Next. Now on the thermal side, it's a little different. And I'll stick with this one for a little while here because it's particularly important for the area that we're talking and the wastes that are available. We have these great big sorting buildings called materials recovery facilities scattered throughout our larger municipal metropolitan areas. MRFs, a lovely name. MRFs sort out all the crud we throw into the trash cans and break it down into categories. And out of that comes a lot of plastic that used to go to China and doesn't much go to anywhere right now. But you get biomass, you get glass, you get metals, and how fine you sift that stuff out depends upon how well you can pay for the things that you get out of the other side of it. Now, an odd example, if you go to one of these big MRFs, I'm talking thousands and 2,800 tons a day right there in Huntington Beach. The last time I checked the permitting, they're going up from there. About half of that stuff ends up just kind of as a smelly, gray, gritty crud that then has to go to landfill. At the current the best we can do on recycling, we don't quite get to 50% of what we take out of that materials recovery facility converted back into something we can put back in the marketing space, and the rest of it goes into the dump. But if you really look at that grit by itself and you apply technology to it, I've found that you have ore grade precious metals recoverable from that material at a rate that probably would pay for all of the processing of that gray grit coming out the other side. A lot of this is just looking closely and paying attention. In a thermal conversion system, you don't want oxygen in there. This isn't burning. This is not an incineration process, although there are those that will scream bloody murder about that comment globally. Realistically, you put stuff into an oven without oxygen and you heat it up enough to where it vaporizes. You collect those vapors and you do something with them. In this case, we can take that producer gas, that raw vapor coming off of it. That's the stuff that is able to be put through catalysis and used as fuel by itself. It is easier to clean. You can put it through baghouses. The gas that is non-compressible comes out as an oil, and that oil is a lot like number 2 bunker grade marine fuel, just as it comes out of pyrolysis. And then you get the hard stuff that doesn't go gas down in the bottom. The percentages of those 3 areas vary depending on what you're eating and what you're converting in the process in the middle. And you can go from, well, for example, tires. Tires are about 15 to 20% polymers and the rest of it natural rubber and silica and minerals. You get about 30% gas, 20% oils, and 10% steel, and the rest of the stuff that comes out the bottom. You can separate that off to where we can take tires apart and convert them, and you don't end up with more than the rocks that came in with the dead tires, and turn it into syngas, into fuel, green fuel, into things like carbon black, and reclaim all of the steel that was in the tires. We are at that point in our technology development now internationally that these things are real tools that we have to work with. Before we get off of this slide, there was a comment made that is certainly well thought, that we want to see demonstration projects. We've been wanting to see demonstration projects of waste conversion since I've been in the field for the last 20 years or so. And fortunately, the demos now are full-scale industrial operations in many cases, somewhere else. So my first question is, can you, not whether you can make a demo, but is there one already built that we can take a look at? Have you proved this out on the ground somewhere? If you can do that, if you can say, here's a technology that has already been proven on the ground, something magic happens on the financing. People will actually put money into it, a novel concept. We want to be able to focus on technologies that are proven. The really radical stuff that's out there in front of us, that's not what we need for something like this. We need scale and capability to make a clean conversion of lots of different kinds of waste. Biomass and plastics are a couple of great categories into things that we can use. And if we focus on technologies that are already proven somewhere that we can look at and see the numbers on and the emission management that has occurred at those places, then we're in a lot better shape, not only for the environmental aspects of what we're trying to do, but for the financial aspects of what we're trying to do. Andrea, next slide. These things integrate. In Denmark, there's a place called Kalundborg. It's on target for me. The whole city is an integrated waste to product process, basically. Many different companies involved, have been for a long time. But they take the wet waste and put it into wet waste processing, and they take the dry waste and put it into dry waste processing, and they hook everybody together in a highly integrated, sensored complex that allows the products to be varied as the incoming materials vary. You need to be flexible. You need to be able to know what your incoming is, not try to do everything with one tool, but fit the tools to the incoming material. And you need to know what your marketplace is for the outgoing materials as well. So this little sketch here that I've put together splits out all kinds of different wastes coming in from most of the major sectors that we have, the municipal, the agricultural, and the forest, and puts that through processing, takes off what we can recycle. We certainly want to do that. But the rest of the stuff goes into some form of conversion process. Thermal, high solids anaerobic, sugar, the ionic liquids, all of these various technologies, if you match them up carefully, you can take apart just about anything that comes to the front door and turn it into product. And that's really the integrated eco park. That is kind of the goal we're all trying to get to. And there are eco parks in the United States. It's more common in Europe right now. But this is the sort of concept, I think, that fits best with both the need for the amount of fuels that we are seeing and the enormous amount of waste that we know is there. And as Andrea had made a mention of in my little bio, worked with Los Angeles County on this for a long time. We've looked at Eagle Mountain and the Mesquite landfills in that territory. We know they're great sites because we can rail to them. But Mexico has just as much waste, and the tire piles are pretty enormous, as the EPA will show you. So we don't have a pinch point on the feedstock. We have a process in the middle. We have a suite of processes in the middle that are now commercially available. There's a lot more out there that aren't quite, but at least of those that are commercially available and internationally proven, we have a good complement that can take apart a lot of stuff. And we know that we can take the process and turn an output then that meets many of the needs that we're talking about here. It's doable. It's doable now. It takes a lot of willpower. It takes a regulatory perspective, and it takes a whole bunch of money. The money can come for a financeable, viable project of this sort. It's not out of hand. It's each of the pieces of that vehicle that we're trying to move this through are known, and we can point to them and say, look, you can do this economically, it's safe, it's clean, it puts a lot of jobs together, and it eats up a lot of trash. I believe this is a concept that, as with Laguna Salada itself, is timely, and it provides the kind of driving force on the energy sector that one needs for something this large for environmental restoration. Next slide. Let's break it down a little bit. we know that we've got an enormous region north and to a lesser degree south of the area that we're trying to work within. And we know that by applying a lot of good, solid numbers and a lot of computerization, we can map out those supply chains. So we're very certain of the fluctuations in the amounts of stuff that we can bring down to that area. And we can do so by rail, which saves a lot of problems. We need to understand the variability not only on a daily, monthly basis, annually, but over a longer period of time, because we're looking at a long-term sustainable operation. We know that there are pre-processing capabilities where that waste is being generated that can take it apart and take it down to smaller pieces, that if they know what they're trying to send out the back end of that, those processes can be tuned to those kinds of going from waste to feedstock, raw feedstock. And it is a computerized process. It's like scheduling all the trains in the world at the same time. But it's possible, and we have the capabilities in our universities and our national labs and our international capabilities to keep track of that kind of information and bring the focus to the feedstock that would feed something of this scale. And then we know also that we can find the offtakes that we need and get contracts for those when we have a large project that needs 9,000 gallons a day of green fuel, as well as the power that has to generate in there. So we have a known capability to manage the input. We have a large complement of proven technologies that provide the process in the middle. And we have a known need for the various outputs that we're talking about. This is an integrated system. I believe quite firmly that we can put this package together, and given the need, the capability of the systems, and the availability of the outputs, we can show a viable long-term solution for the waste management side, focused on providing the backbone, if you will, for this large of an effort on the environmental side. Next slide. Let's make it really simple, huh? we just want to take the stuff we throw away and turn it into the stuff we need. And we can do that now. We can do that now. And we can put that input, process, output linkage as the core for our circular economy in this place in between our countries and make it work. Next. And that's me. And I think we got time. I was trying to push through a little bit because I would suspect in the things that we're talking about that there are going to be some questions, Nathan, if you'd like to manage a Q&A.
Yeah, we're looking at questions right now. I mean, for me, I think it's extremely viable, the scalability of it. So we're looking at, large infrastructure along a rail, but we started deploying and investigating smaller deployments in places like Salton City, where they have the EDCO facility at the airport. It'd be great if we can interject a smaller version of this as a pilot for how you could do it within a community there. The microwave technology is very interesting. I learned a lot just from this overall presentation, but the financeability is very interesting. The project, maybe you can give a little background on what you think, what kind of coordination would need to take place for the other project that is along the rail. Dre and myself, we've been working diligently on trying to get into the sticks about, how and why and what land leases or what coordination with which municipalities would have to take place to get that project off the ground. And, again, go back to the conversation about NAB Bank. Is there a way that we can get a funding strategy, because we know that there's products that can be processed. Just me personally, I put a peanut butter, jar that's plastic. I'm supposed to wash the whole thing out, right? And that's just not how people actually think about plastic. A, it's an education. B, I read it on the side of one of the recycling trucks that it has to be clean, but there's not really an education to no, you can't just put the thing that has a little recycling logo on it into the recycling and expect it to be recycled. Those thin films have those on it, like a bread bag, right? Those things that we think can be recycled, but in actuality, it's just a branding stamp so that people can feel good about selling a product. So maybe just, I mean, that's a lot to unpack, but from
Sure.
project development to the education standpoint, that's why we're here today.
I followed my mother out to their 3 trash cans in Bellflower one afternoon, helping her with her trash in her 80s. And she just basically took everything in a trash can and dropped it in the blue bin. I said, Mom, you can't do that. They're not, those things aren't recyclable. And she looked up at me with her big eyes and said, well, they should be. What a perspective. Okay, let's back up a little bit. You want to get down in the weeds. Working with Los Angeles County, one of the areas that I was looking at is the unit train out to the Eagle Mountain landfill. I realized at that time in the work that I was doing that one can enter into agreements with the rail haul easement authorities and put processing and loading stations in, say, a large rail yard. You put a couple of those up in the Los Angeles area, and you can go from your materials recovery facilities into chip grind process and load unit trains and take it south. So it's easier in many ways from the permitting side to work with the railroad within their easements like that. One thing to keep in the back of your mind. I was integrally involved in trying to get the biomass plant there out in Mesquite up and running. It never really flew, but there was a lot of reasons to look at biomass management in that region, and still are. So of the two things that we kind of kicked over the most today, plastics and biomass are probably the nearer targets that we can work with. Both of those have, especially the biomass, have large-scale proven capabilities of being converted into useful products and materials and heat and power. But we are seeing a diversity of projects across the globe that can take most of the things that get mixed up in trash in the municipal solid waste and pick it apart and get most of them. A company called Envol takes those cute little packets that we put drink in. It's aluminum sealed against plastic. And how do you do that? Well, they take pyrolysis and they vaporize the plastic off, and they take the aluminum, melt it down, and recover the aluminum out one side and take the plastic out the other as a vapor and back into fuels. The technologies have become available. I'd
like to back up for a second on, so biomass conversion facilities, part of the reason that they're a little bit ahead in the race is because of the credits that they get for greenhouse gas emission reduction through diversion from the landfill. And plastics currently don't have good designation in that way. So right now, because there's been a misnomer that plastics live forever, they have been designated like coal in landfills, and so don't have those same greenhouse gas reduction credits that are associated with them. But what we've shown and has been proven definitively with research and with publications is that yes, plastics do break down, and they break down pretty readily, and they are an important part of that equation, and they really should have credits attached to them when we divert them from landfills.
You know that wonderful taste that as a kid you got out of the hose when you drank out of the hose on a hot summer day? A lot of that was phthalates, and that's when it comes out. How great is that? Nathan, we can, and I'm more than willing, as Andrea knows, to really get into those sticks with you and down into the weeds. I've spent the last 20 years tracking projects internationally in companies and technologies, and that entire database is at your disposal. Well, anybody who'd like to dig into this, I'm shoulder to the wheel.
Yeah, I think that's the most important thing, Michael. When we're having this conversation, we're saying jobs, right? Buildings, development, in easements, in places that are easily accessible, green jobs, right? We might think of plastic as being a black job, or a tar, or a dirty job, or something that deals on the side of it not being a green economy, but really it is. We need to start from the very beginning, which is how do we make all those plastics biodegradable? There was a great beer company that did that with their 4 or 6 ring beer packaging holder that now fishes and turtles can use that as a food source. So yes, we have policy that's trying to turn away from single-use plastic bags. Every store still has single-use plastic bags in California, right? There's a certain like justification. Yes, the thicker ones that are used in the grocery stores are recyclable, but how do we recycle all of that other stuff that has peanut butter on it, or all of that other stuff that, you know, people aren't cleaning? And I think this is what we're saying is, you know, a big majority of that could be point source processed in the local community, but those things that are a little bit more difficult go to a place like Imperial County, where it's far off the beaten path from any residential areas. It's in an area that has rail. It can process all of that stuff and start producing products that can go towards dredges, towards any kind of other resource, or tied directly into the energy grid. Tying it into the energy grid adds to our green economy and adds to our green type of infrastructure. So these really are infrastructure projects, and they really are how you get projects and people on the ground working. You just mentioned, Michael, at least 50 projects within California, right? Like you have one in Torrance, you have one in, 10 in San Diego, because we have 10 different, this is how we kind of work our way out of, our economic depression. And with a green jobs corps or something like that, this is where you deploy people that want to have those skill sets and want to learn about new projects. So take us into the weeds. We still have a few minutes to go. Overall discussion pieces, though, is really important in just thinking globally, right? These are not projects that are just here, as Dre mentioned, trying to incentivize somebody to go into the ocean and pull out plastic fishermen, incentivizing people in India to scrap and pull things out of the Ganges, right? And process that on their facilities in China. If this, we should have a trash credit, right? We've talked about water credits. We've talked about carbon credits. There should be a trash credit, but in actuality, there already is 5 cents per bottle, right? So that economy is there. It's just a matter of needing financial support from a federal or a local government to partner with us to take these to a bank, to take these to other institutions. So yeah, please continue. I mean, I love where the discourse is going.
And so here's another aspect of what you're talking about. So when you create a valuable product using technology, whether it's synfuel, whether it's avgas, whether it's direct to energy grid, what you're doing is raising the value of that product. And that allows you to pay money, fair wages, to the people who are collecting those products and giving you the feedstock that you need. So now those fishermen who are out of work because their fishery has collapsed, or maybe it's off season, can go out and pick up plastic and get a fair wage for it, just like they're getting a fair wage for a day of fishing, no matter where they are in the world. It's creating that kind of uniformity on economy and cost, so that we're not paying people slave wages to go clean up their environment that we trashed with our debris that's floating to them on some current. They're actually getting a fair wage for it. So it doesn't become a slave job anymore. It actually becomes a job.
Yeah, and one of those jobs that you're proud to do. Like you mentioned, you shared one of your friends, they had the biggest haul off of the coast of Hawaii of fishing nets. That's something that you're proud to come home to and say, I've gotten an award for the most trash cleaned up. And there are a lot of organizations doing that,
Well, that was 270 tons out of the middle of the North Pacific. And this summer, they're going to remove 1 million pounds. So, that's not like a small check. I removed one 2-ton net. That is a tremendous amount of value and work for our planet. And it's a tremendous relief to those small phytoplankton that are doing their job and creating oxygen for us.
Yeah, that's absolutely astounding. Well, and I wanted to get into this a little bit briefly, because we're going to mention this in future discussions, but like there was a discussion, I've been keeping my ear to the news, but uranium mines, the New River, these are toxic areas. I really like this bridge between, hey, we have people that can do it, but in those dangerous situations, we can deploy this robotic fleet to go in there. That's what I see Boston Dynamics robots as. They're trash picker uppers. In addition,
well, plants are good trash picker uppers.
Dance too.
Plants are good trash picker uppers too. And in the New River and Alamo region, there is a great need for phytoremediation. And I've shared with you, I believe, in the past, the quantities that we're looking at. If you get plants in there that suck up all that crud out of those drainage canals, that's a lot of biomass to be converted. I want to touch on one thing since I got a minute or so here left. Mr. Simpson's concerns with the tribes. Tribal work is near to my heart. I am currently working with a number of tribes on these kinds of conversion technologies, to tell you the truth. And the conversion of biomass and the conversion of plastics in particular rise high on their list. So there is direct and immediate interest from many of the various tribes across the country, especially in California, to take part in development of and implementation of conversion of these biomass and plastic waste and others into jobs and into cleanup for places like the Emerald Triangle, Sonoma, and Mendocino in the fire areas. But Rob, that was some good points. I've worked within the region there of the Four Corners and the tribes up in that area quite a bit in my life, and so it's an ongoing task of mine that I set myself to try to make certain that we certainly include tribal relations, sovereign nations relations, each side of the border as well as in the United States.
Thank you, Michael. Appreciate it.
Yeah, and I think this is one of those, we're going to talk about this later, what you just mentioned, cleaning biomass in the rivers. We're going to have a whole panel that's going to be 2 hours. We're going to have a Q&A in that section as well. The Alamo and the New River, everybody thinks we need a wastewater treatment facility. The TJ River, we need a wastewater treatment facility. The alternative is capture and divert as much trash as humanly possible at the onset and deploy the islands, deploy the on-land phytoremediation and phytomining solutions, right? It's a different paradigm and it costs much, much, much less, right? So that's kind of why we're having this discussion, is to introduce this to other countries, to our own country. Hey, trying to get grants for these things are so difficult. With us doing it, if Michael's doing it on his own and Dre's helping him and they're trying to work together on a grant, it is almost an insurmountable task because you have that big wastewater treatment facility ready with their package and their $100 million ready to start putting into their grant writers. It's kind of the David and Goliath, but I think we're having that conversation now, and we have many, many Davids on this line and listening out there in the internet space. So I really want to appreciate and I want to thank both Dr. Andrea Neal and Mr. Michael Theroux for joining us today and sharing some really great content, really great things to think about. And just to let everybody know, this is a project we just described here, 2 projects in Imperial County. We can have 2 or more projects in Mexico, in and around Mexicali, of equal or greater size. And it's really that opportunity to start getting these viable financial models in place that we can start building our other projects with, creating kind of the backbone. So that was a great piece. Thank you so much for sharing all the information. I didn't see any questions, but we'll feel free to share those along if we get any in the coming days. We can share those as well.
I will be available.
Thank you.
Perfect. Thank you so much. Thank you, Michael.